Hey guys, welcome back to another chemistry lesson. This lesson is going to be on the International System of Units, which are the units of measurement that we use in science. First, units are the standard quantities used to specify measurements, and they are critical to chemistry. The most common units of measurement used in the world are the metric system, which is most of the world, and then the English system or the imperial system, which is what we use here in the United States. Scientists use the International System of Units, or SI units, which are based on the metric system. And I know what you're thinking, if it's the International System of Units, why is it SI and not IS? That's because the SI comes from the French name for it, which is Système International. Sorry, I'm not French, but anyway, the S comes first in the French name, and that's where the SI comes from. Now, the standard units for SI measurements are length, mass, time, temperature, amount of a substance, and electrical current. So, meter, kilogram, second, Kelvin, mole, ampere, and candela. The 5 most relevant to general chemistry are these 5. The other 2 units are more relevant to physics or more advanced chemistry. So for this course, you need to know the meter, the kilogram, the second, the Kelvin, and the mole. So really quickly, there is a difference between mass and weight. Hopefully you have already learned this, but if not, you're gonna learn it today. So the mass is a measure of the quantity of matter within an object. So it's how much stuff is in that object. Weight is a measure of the gravitational pull on the matter in an object. So, for example, my mass on Earth and on the moon are going to be exactly the same because I have the same amount of stuff in me, whether I'm on Earth or on the moon. My weight, however, will be different on Earth versus the moon because the gravity on the moon is about 1/6 of the gravity of Earth. So, my weight will be about 1/6 of what it is on Earth on the moon. So they are different, but for the purposes of this class, I will likely treat them the same. All right, so just to give you some perspective on units, because I know that many of my students are from America, the United States, and so we are more familiar with the imperial system. So just to give you a little bit of perspective, a meter is slightly longer than a yard, a little bit longer than 3 feet. It's about 3 feet, 3 inches. A kilogram is equal to 2.205 pounds. More commonly used in chemistry is the gram. A kilogram is a lot of stuff, and that would be very, very expensive for us to be doing very large scale experiments like that. So we will be using the gram. And a kilogram is 1,000 grams, or 1 gram is 1/1000th of a kilogram. And then the Kelvin is more closely related to Celsius than Fahrenheit. You need to know the Celsius temperatures and then be able to convert in between the two. So for just some perspective, the freezing point of water is at 32 degrees Fahrenheit for us Americans, which is 0 degrees Celsius. The boiling point is 212 degrees Fahrenheit, which is 100 degrees Celsius. To get from either of those to Kelvin, we need to get into Celsius first using this equation here. And then we can then get to Kelvin by just adding 273.15. The size of a Kelvin is the same as the size of a degree Celsius. So if I increase by 1 degree Celsius, I am increasing by 1 Kelvin. The difference is about what they mean. Kelvin is related to the molecular movement, and so we will discuss it later in this course, but what we will not be doing is discussing that right now. Now, you will remember that on the previous slide, there were only 7 units. That's not the units. That's not all we've got, right? So if it was not one of those 7 standard units, everything else is a derived unit, which is a unit that is that comes from other units. It is derived from some sort of math with other units. So for example, density is related to mass and volume, right? So density is a derived unit because it is derived from the mass and the volume, right? So we can calculate density by doing this math, and then whatever math we do to our numbers, we also have to do to our units, which is where we get the derived unit. So because it is grams divided by milliliters, our derived unit is grams divided by milliliters, which we say as grams per milliliter. Anytime you see the division, it's per. Another example of a derived unit is volume. If you recall, there was no standard unit for volume, so instead we have to derive that unit from our length. So we had meters for length. In this case, I'm going to use centimeters, but I can get the volume by doing the length times the width times the height, which gives me centimeters times centimeters times centimeters, or centimeters cubed. Now, we call that a centimeter cubed a milliliter in chemistry, and it is very useful for anything that we need to talk about using volume. But this is not a standard unit, it is a derived unit. So anything that was not one of those 7 that was on that list is a derived unit. Now, metric units are so much easier. I understand that as people from the US, this is not something we are familiar with. However, it is so much easier than the imperial system because there are prefixes that indicate our multipliers, and they are multipliers that represent the power of 10. So the prefix kilo, for example, means times 1,000. So a kilogram is 1,000 grams. A kilometer or kilometer is 1,000 meters. We don't have that ease in the imperial system. Like 12 inches is a foot, 5,280 feet is in a mile, but a nautical mile is different than a mile. So the metric system, which then gives us the SI system, is really so much easier to work with, which is why we use it in science, and it's used everywhere else. So the United States just gets to learn a different type of unit. So these are the prefix multipliers. We start with really, really large prefixes like exa, which is 10 to the 18th. So that's million, lots, many. And you can see that here. So an exagram, if I were to say exagram, I'm talking about like the mass of a planet or something like that. It's crazy. So really, really big. When you start getting to something that's more relevant and something you've probably used before, we've got giga, which means a billion. So a gigabyte, like on your phone, the memory on your phone, a gigabyte is 1 billion bytes. Other relevant ones include mega, kilo, deci, centi, milli, micro, and nano. These here are the ones that are really important for general chemistry. These are the most relevant ones for this course. If you were to continue into more advanced chemistry or something like quantum physics, then our very small ones, pico, femto, and atto, become much more relevant. These, now that we, get down to this size, we're talking about like the size of a proton or the size of an electron, or even our quarks and other subatomic particles that are even smaller than our protons and electrons. So the smallest thing that general chemistry talks about is wavelengths of light. We can get down into this area, but what we generally do, if we're talking about things that are very small, is talk about them in scientific notation and just use meters. So, if you're in my class, what you need to know is the prefix the letter that represents it, so like the big G for giga, for example, and the number multiplier, both as number and as scientific notation. Because if you're going to understand chemistry at all, you need to understand the units that we use to talk about chemistry.